All right. So here's kind of our summary. I try to go through and look at test and study guide, which you guys already know. They're very similar. I'm not out to trick you. And summarize all the different things that we need. So first of all, when we started this, we were using the definition of the derivative. You will have to do one or two using the definition of a derivative on the test. You can certainly use our shortcuts to check yourself, but if I say use the definition and you just write down the derivative, you're not going to get credit for it. So our definition is the limit as h approaches 0, f of x plus h minus f of x all over h. So you have to know what that is. I'm not going to give you that formula. I'm just going to say use the definition to do it. Make sure on that you write the limit on every step. When is the place where you can drop off that limit? When you plug in the 0. Okay, up until that point, you write your limit on every step. We also, in that beginning piece, talked about the applications. What is a derivative? And remember, a derivative is the slope of a tangent line. So a slope of a line is talking about a rate of change. So anytime I'm talking about a derivative, I'm talking about the rate of change. In terms of like one specific application, we know position is your original equation. Sometimes that's called S. What is velocity?
Second derivative. Or the derivative.
Yeah. S prime is your velocity, derivative of position is velocity, and acceleration is second derivative. So make sure if I ask you to find velocity or acceleration, you know if you're finding first or second derivative. All right, so let's do a few problems. If I ask you to use the definition to find this derivative, so you have to write the limit, h approaches 0. F of x plus h means you go to this equation, you replace every x with x plus h. Minus f of x is the original. All over h. Okay, f of x plus h squared. So can I square that and distribute my 3 at the same time? We know x plus h squared, we've seen it many times, you have to FOIL. So that would give us a 3x squared. We would have 2xh times 3, so 6xh. H squared times 3, so 3h squared. Minus 4x minus 4h plus 1. If I go ahead and distribute my negative through here, minus 3x squared plus 4x minus 1 all over h. Can I plug in my h yet? No, I'm getting 0 on the bottom. So if we simplify, 3x squared and negative 3x squared cancel. Negative 4x and positive 4x cancel. 1 and negative 1 cancel. So we get 6xh plus 3h squared minus 4h, all divided by h. So if we take an h out of everything, that gives us 6x plus 3h minus 4. Now you plug in a 0 for your h, so that's the point when you actually drop it. Drop that limit symbol. And so we just get 6x minus 4. Second one. Find the acceleration at 5 seconds if the position is given by this formula. Okay, in order to get acceleration, what do I have to do? Derivative. So if I do the derivative of this, it doesn't say definition, so we can use our shortcut. What would that give me?
2t squared, or sorry, 3t squared minus 8t plus 2.
Okay. What does this equation represent? Mm-hmm. So to get acceleration, we need the derivative. Again, we need to know how the velocity is changing. So if we do that, we get 6 t minus 8. That's our acceleration. Now what do we do?
Oh, insert the,
Why can't you plug the 5 in before we do our derivatives?
Don't need it. The derivative will be 0.
So you can't plug in numbers until the very end. So we get 22. Acceleration would be meters per second squared. Or feet per second squared, I guess I didn't tell you what we're measuring in. Third question here. If R of X measures the revenue of producing X items, what does R prime of 20 equal 150 mean? So I'm asking you to write a sentence telling me what this means. Let's talk about units first. What would the 20 be?
items,
What would the 150 be?
your revenue.
Revenue, so that would be dollars. Okay, so I know I have 20 items, $150. R is revenue. So does that mean if I produce $20 or 20 items, the revenue is $150? No, because it's R prime. A derivative is a rate of change. So it's saying when 20 items are produced, the revenue is the revenue increasing or decreasing?
Increase.
Increasing, because it's positive. $150 per item. Okay. Rate of change, so something per something. So it doesn't tell me how much money I bring in if I produce 20 items. But what it tells me is if I produced an additional item, so if I made 21 items, I would expect to bring in an additional $150. So derivative is a rate of change, something per something. Doesn't tell you the actual revenue, just how the revenue is changing at this point. If it had been a negative, it would mean you are losing revenue, or it's decreasing at that point. All right, any questions on these first three examples? I want you guys to take a minute and try the next two on your own. I'll put mine up here because they are color-coded. That might help a little bit. Take a second and see if you can get these. All right. Best option on these problems is to just pick one to start with. I usually start with the one with the most curves to it. Not necessarily going to be the original function, but it just gives me a starting point. So if I started with this red one, here we would have a horizontal tangent line. So the derivative would be 0. Okay, so the blue one looks promising. Let's see if that continues. So horizontal tangent, horizontal tangent. The graph was decreasing, so derivative negative. Increasing, so derivative positive. Decreasing, so negative. Increasing, so positive. So I know the blue one is the derivative of the red one. Now, green is either my original or my integral. So let's check the derivative of the blue one. So horizontal tangent, so derivative is 0. Horizontal tangent, so derivative was 0. Increasing, so derivative positive. Decreasing, derivative negative. Increasing, derivative positive. So the green had to be last. So this was the original. This is your first derivative. And this is your second derivative. Did you guys get those? This one, I want you to graph the derivative. So we look. Derivative would be 0. Yeah. until this, my function was decreasing. So that means my derivative has to be negative. Okay, then my function's increasing, so my derivative has to be positive. And then my function's decreasing, so the derivative is negative. So something like that. On those, I'm checking, do you have the correct x-intercepts, correct positive or negative on your graph? All right, so tell me, looking at the graph of a derivative, what are the 3 places where the derivative does not exist?
Discontinuous.
So if there's any kind of break in the graph, there is no derivative there. Where else would we have a place where the derivative doesn't exist? A corner, good. Any sharp corners, there is no derivative because the tangent line isn't unique. Third option,
Vertical tangent.
because the derivative is the slope of a tangent line, slope of a vertical line is undefined, so there's no derivative at a vertical tangent. All right. The derivative is going to be 0 when what is true?
The tangent line is flat.
Mm-hmm. So call it a horizontal tangent. Or another way of thinking about that, those are like the maxes and mins on your graph, where you change direction. When is a derivative positive?
It's increasing.
Mm-hmm. And when is a derivative negative?
It's decreasing.
Any questions about that stuff, the graphs or characteristics? You need to know all of our special derivatives. So, what is the derivative of e to the x?
Yes.
What is the derivative of sine x?
Cosine.
Remember, sine and cosine, their derivatives are very similar. What's the derivative of cosine?
Negative sign.
All the codes have a negative derivative. What's the derivative of tangent?
Secant squared.
Okay, tangent and cotangent have very similar derivatives. The codes all have a negative derivative. Derivative of cotangent would be,
Negative cosecant squared.
okay, derivative of secant is,
Secant x tangent.
okay, so secant and cosecant derivatives are similar. Derivative of cosecant is,
Cosecant cotangent.
so all 6 trig functions are going to show up on this test somewhere. Make sure you know your derivatives. Product rule. If we have an f of x times g of x, how do we do the derivative?
F of x times g prime of x plus f prime of x times g of x.
So product rule, you do one derivative at a time and add them together. Does it matter if you did f prime g of x first? No, we're adding, order doesn't matter. Quotient. If you have 2 functions being divided. So it's low, so the bottom, d high, minus high, d low, derivative of the bottom, over low, squared. So low d high minus high d low over low squared. Make sure you are using product and quotient rule correctly. All right, any questions there? Those are really just things that you should have memorized at this point. The remainder of this, I just put some problems for us to practice. So this first one, if I want to do the derivative, is there any way to rewrite this so I don't have to do the quotient rule? No, because I have x on top and bottom. Because it's e to the x and multiple terms on the bottom, I can't divide them. So we have to do quotient rule. So low, 5x minus 4, d high. What is the derivative of 3e to the x? Minus high. D low, what's the derivative of the denominator? Over low squared. All right, I expect you to do any obvious simplification. So if there's, things like terms to be combined or basic multiplication, we can do that. At this point, we can distribute. We don't have any like terms. You could also just take out that 3e to the x, which might be the nicest option. Then we're left with 5x minus 4 minus 5, or 5x minus 4 squared. And that's 5x minus 9 over 5x minus 4 squared. Questions on it? Do you guys want to try a couple on your own and then we can check them together? So, do some derivatives and we'll check ourselves. At the very least, you probably need to rewrite. The fifth root of x would be x to the 1/5 power. Bless you. I put this on here intentionally, 1 over 4x to the third, because we've had problems on the homework and people are writing that one wrong. When you do that, it's just the x that we're bringing up, so it's 1/4 x to the negative third times cosecant x. Now I can distribute the cosecant, but is that really going to help me? No, because I'll just have two different terms and I have to do product rule in both of them. So it's just going to make more work. I would just do product rule from here. So derivative of the first, 1/5 x to the 1/5. So the 1/5 comes down, x, if you subtract 1 from the power. So 1 over 5 minus 5 over 5 would be negative 4 over 5. Next term, if I bring down my negative 3, so 1/4 times negative 3, minus 3/4. X, if you subtract 1 from the power, negative 3 minus 1 is negative 4. So derivative of the first times the second plus the first derivative of the second. What is the derivative of cosecant x?
Negative cosecant cotangent.
As far as cleaning this up, there is not much you can do. We have two terms, they both have a cosecant in it, so you could take that out. If we did, we have 1/5 x to the negative 4/5 minus 3/4 x to the negative 4. Since this was a minus, we need it to be a negative and a cotangent through this parentheses. So it would be minus x to the 1/5 cotangent x minus 1/4 x to the negative 3 cotangent x. So not that the the actual product rule itself was so ugly, but the answer certainly was. Make sure you are taking the time at the beginning to rewrite anything you need to, any x's on the denominator when you bring it up, it's a negative exponent. If you have radicals, write those as fraction powers, and then just do your other rules as needed. Questions on that? Next. Is there any way to rewrite this so I don't have to do the quotient rule? No, there's two terms on the bottom, so I can't. So, let's do our quotient rule. So low. D high, what's the derivative of tangent?
Secant squared.
Minus high. D low, derivative of 4 is 0, so that would go away. Minus 7 times the derivative of cosine. So derivative of cosine is negative sine. So two negatives make a positive. Over low squared. There's really not much you can do here. If you wanted to distribute your negative or your secant squared, you could. If you recognized it, you could simplify a secant and a cosine, but you'd still have a secant in that term. So that's really all I would expect on that one. Next one. What should we do? Want to do quotient rule? Okay. So low. D high. What's the derivative of 5 sine x?
Just negative, or cosine.
So the coefficient always go down with it?
Yeah.
Once attached to it?
Think of it, it's like 5 times the derivative of sine,
Okay.
and so it just ends up staying in front. Okay, so low D high minus high D low. What's the derivative of cosine?
Negative sine squared, or negative sine.
Low squared. We get 5 cosine squared x plus 5 sine squared x over cosine of x squared. Is there anything we could do on this one? Yeah. If you take a 5 out, you're left with cosine squared x plus sine squared x. What's cosine squared times sine squared? So 5 times 1 is 5 over cosine squared x. Or you could even write that 1 over cosine, reciprocal cosine is secant. So it could turn into 5 secant squared x. Okay, different equivalent forms. But I would like, if you see a cosine squared plus a sine squared, I do want you to turn that into a 1. I would take either of these answers. Did anyone do that problem differently? If you caught it at the beginning, there's only one term on the bottom. What's sine over cosine? So it's 5 times the derivative of tangent, which is secant squared. So you could get 5 secant squared x that way as well. All right. Is this okay? 2 more problems. All right, this one I am asking for the second derivative. So we do our first. Derivative of the first, so that's 12x cubed minus 18x squared plus 2x. Derivative of negative 5, that just goes away, times the second plus the first times derivative of e to the x is e to the x. Strongly recommend cleaning this up. If you take out your e to the x, then you can combine like terms. So we have a 3x to the fourth (12x cubed minus 6x cubed is 6x cubed). Negative 18x squared plus 1x squared, so negative 17x squared. Plus 2x minus 5. So second derivative, we do the derivative of that. So derivative of the first, derivative of e to the x is still e to the x times this other stuff. Plus e to the x times derivative of the inside. So derivative of 3x to the fourth would be 12x cubed. Derivative of 6x cubed is 18x squared minus 34x plus 2. Both terms have an e to the x, so if you take that out, you can just combine like terms. Is it okay if I just add like terms from here? So we'd have the 3x to the fourth, 18x cubed plus x squared minus 32x minus. Polynomials or derivatives get nicer as they go. Anything with an e to the x or a trig function typically doesn't. Any questions on that? Okay. The last problem that I have prepared. Find the equation of the tangent line to the curve y equals 4x minus 1 over 4x plus 3 at the point negative 116. Okay, we know if we need an equation of a line, we have to have a point and a slope. I gave you the point. How do I find the slope of my tangent line? Derivative. Okay, so I would have to do quotient rules. So low d high minus high d low, derivative of bottom is also 4, over low squared. So if we start multiplying things out, we get 16x plus 12. In this parenthesis, I have to distribute my negative and my 4, so minus 16x plus 4. 4x plus 3 squared. My 16x is canceled, so we just get 16 with 4x plus 3 squared. That's my derivative. Now what do we do?
Plug in your negative 1.
16 over negative 1 squared, which is 16. So then if we plug into y equals mx plus b, we get b equals 32, so our line is y equals 16x plus